Hello, Accelerated Chemistry students. This is Ms. Christopher, and this is your Chapter 16, Section 4 video notes all over calculations involving colligative properties. So let's first start talking about molality and mole fraction. So let's recall that colligative properties of solutions depend only on the number of solute particles dissolved in a given amount of solvent. So chemists use two ways to express the ratio of solute particles to solvent particles: molality and mole fraction. Molality is the number of moles of solute dissolved in 1 kilogram or 1,000 grams of solvent. So molality is also known as the molal concentration. So the equation you need to remember is molality, which is little m, is equal to your moles of solute over your kilograms of solvent. Molality is not the same as molarity. Remember, molality refers to moles of solute per kilograms of solvent, and molarity refers to moles of solute per liters of solution. So let's look at a sample problem. So how many grams of potassium iodide must be dissolved in 500 grams of water to produce a 0.060 molal potassium iodide solution? So according to the definition of molality, the final solution must contain 0.060 moles of potassium iodide per 1,000 grams of water. So we're going to use molality as a conversion factor to convert from mass of solvent to moles of solute. And then we're going to use the molar mass of potassium iodide to convert the moles of potassium iodide to grams. So we're going to go from mass of H2O to moles of Ki to grams of Ki. So we know our knowns and we know our unknowns. So now what we're going to do is we're going to make that conversion from molality so that we can convert grams of water to moles of Ki. So here is the conversion factor that we're going to use. And then we're also going to use the molar mass conversion factor to go from moles of Ki to grams of Ki, and that is this formula. Now we're going to multiply the known solvent volume by the conversion factors. So we have 0.5 kilograms. We're going to multiply that by 0.060 over 1 kilogram, which is the molality. Then we can make sure that our kilograms cancel. Then we're going to multiply by the molar mass. And when we do this, our moles cancel, and we're left with 5 grams of potassium iodide. So it makes sense because 1 mole is 1 molar mass of potassium iodide. We are getting something that's less than a mole, so the molar mass should be less, or the mass that we have to measure out is going to be less than the molar mass, which it is. And then we have to make sure that we have our answer in 2 sig figs, which we do. The concentration of a solution can also be expressed as a mole fraction. The mole fraction is of a solute in a solution is the ratio of the moles of that solute to the total number of moles of the solvent and solute. So in a solution containing Na, which is moles of solute A, and Nb, which is moles of solvent B, then mole fraction can be expressed as the following equation. So if you are talking about your solute, so that's going to be Xa, you would take the moles of your solute over the total moles of your solute and solvent. And then if you're talking about the solvent, you would take the moles of the solvent over the total moles for the solution. So note that mole fraction is a dimensionless quantity. So that means that our units are going to cancel. So let's look at an example problem. So ethylene glycol is added to automobile cooling systems to protect against cold weather. So what is the mole fraction of each component in a solution containing 1.25 moles of ethylene glycol and 4 moles of water? So first, we're going to list our mole amounts for each, our solute and our solvent, and then we're going to use the equations to plug in and solve. So the first thing we're going to do is we're going to identify our knowns and our unknowns as always. Then what we're going to do is we are going to rewrite the equation so we can solve for ethylene glycol and for water, and that's what they're going to look like. And note that our denominator is going to be the same because it's the whole thing is still going to be the same regardless whether we're looking at the ethylene glycol or the water. So now let's plug in some numbers. So here we go. We're going to plug in some numbers and get some answers. Pretty straightforward. We like these problems. These are plug and chug problems. Now, could I ask you to solve for the mole amount? Absolutely. And then does it make sense? We have to make sure that the sum of our mole fractions equal 1, because remember it's part over the whole, and the whole would be a 1. And then each answer has to be expressed in the correct sig figs, which they are. So the concentration of a solution. All right, so now let's talk about freezing point depression and boiling point elevation. So the depressions of freezing points and elevations of boiling points are usually quite small. So we could either measure it with a really precise thermometer or we can calculate them. And so let's talk about how to calculate them. So we would have to calculate the freezing point depression or the change in temperature, and it's going to be based on the molal concentration. So remember, if we're looking at these, and we talked about this in the gizmo the other day, the solution is going to have different properties than the pure solvent. The freezing point is going to go down, the boiling point is going to go up. So we're going to figure out how much of a change that's going to be. So the equation for the freezing point depression is delta TF is KF, and KF is a constant. It's the molal freezing point depression constant, and it's specific for specific solvents. And then little m, remember, is our molality. And our molality is going to be determined also by how many particles we have in solution. The boiling point elevation is the same equation, except for Kb is the molal boiling point elevation constant. And again, it's going to be specific for your different solvents. So here are some common values of Kf and Kb depending on your solvent. For most of our calculations, we're going to be using water, so you're going to have to remember the 1.86 for Kf and the 0.512 for Kb for water. All right, so now let's calculate the freezing point depression of a solution containing 100 grams of ethylene glycol in 0.5 kilograms of water. So we're going to calculate the number of moles. Then we're going to calculate the freezing point depression using the formula delta TF equals KFM. So we're going to list out our knowns and our unknowns as always. And then we're going to set it up. So we're going to use molar mass to get to moles. Then we're going to calculate our M, which is going to be the moles of our solute over kilograms of our solvent. So we get a 0.3 or 3.22 molality. And then we're going to plug it into our KF expression. So 1.86 is the KF for water. And then our molality is 3.22. So when we multiply that together, we get 5.99. And then remember, it's the freezing point. So that is the change in temperature. So then we're going to take 100 minus that number to get negative 5.99 degrees Celsius. So that will be the new point at which this solution freezes. And so we have to remember that it's so small and that we are going to be using that number to subtract it from what it should be because our freezing point should go down. Now let's talk about the boiling point elevation. So what is the boiling point of 1.5 molar NaCl solution? So we're going to, each formula, we know that NaCl dissociates into 2 ions according to the following equation. And we know that our molality concentration is going to be twice as much because we have 2 ions in that solution. So it's going to be 3 molal. And then we're going to calculate the boiling point elevation using our equation. So here we go. Knowns, as always, and our unknowns. And then let's plug everything in. So we're going to plug everything into our formula. We get 1.54. And then remember, we're calculating the boiling point. So we have to add that change in temperature to 100 to get our final boiling point of 101.54 degrees Celsius. And that is the end to your Chapter 16, Section 4 video notes. And as always, all the information on these Google Slides has been acquired and adapted from Pearson Chemistry's 2012 edition textbook resources CD and pearsonchem.com. Thank you so much. Have a good night.